Hello children, welcome back to Fari's Educational Companion. Hope you are well, staying safe and healthy. In the last class, we have discussed 8th grade physics, force and pressure. Today, we are going to learn 8th grade chemistry. The lesson materials, metals and non-metals. Before going to start the lesson, let's recall what are materials and examples of materials. Material is nothing but the matter from which a thing is or can be made. Iron, coal, wood, plastic, glass, aluminium, copper are some examples of material. Materials can be classified based on their appearance and hardness or softness. They can be shiny or dull, soft or hard. You have learned these all in smaller classes. Today we will learn metals and non-metals in detail. Let's consider an activity. Take a small iron nail, a piece of thick aluminium wire, a pencil lead and a piece of coal. Strike the iron nail with hammer. Try to hit hard. What did you observe? Hit the aluminium wire also like this. Then repeat the same kind of treatment on the coal piece and pencil lead too. Observe the changes. Do you find a change in the shape of these articles on beating? You can see that the shape of iron nail and the aluminium wire changed on beating. If they were beaten harder, these could be changed into sheets. But the materials like coal and pencil lead do not show this property. When materials are harmed, some of them break into smaller pieces, whereas the others spread into sheets. On this basis, we can classify materials into metals and non-metals. Materials that spread into sheet while strike with a hammer are called metals. Whereas the others which break up into pieces are called non-metals. Do you know the materials which are metals? Iron, gold, aluminium, etc. are some examples of metals. Generally, we can say that metal is a substance that is a good conductor of both electricity and heat. Metals are solid at room temperature except for mercury, which is liquid at room temperature, and gallium is liquid on hot days. Metals can be distinguished from non-metals based on their physical and chemical properties. Today, we will learn the physical properties of metals and non-metals. First, we'll discuss about the physical properties of metals. As we discussed, you can see that when we strike or beaten harder, a piece of iron could be changed into sheets. The property of metals by which they can be beaten into thin sheets is called malleability. Metals are malleable. You might be familiar with silver foil used for decorating sweets. You may have seen that aluminum foil is used for wrapping food. These are examples of malleability of metals. Let's see more examples for the malleability. Metals like iron, steel, aluminum, copper, gold, silver, etc. are examples of malleable metals. Gold is the most malleable metal. But metals like sodium and potassium are very soft and can be cut with a knife. Mercury is the only metal that is found in a liquid state at room temperature. These are exceptions. You can see that when we strike or beaten harder, a piece of iron or aluminum can be drawn into thin wires. The metal copper also can be drawn into thin wires. The property of metal by which it can be drawn into thin wires is called ductility. Metals are ductile. Gold and platinum are the Earth's most ductile metals. But gold has significantly greater ductility than platinum. Other examples of ductile metals are iron, copper, aluminum, zinc, nickel, tin, lead, tungsten, etc. Do you know why cooking utensils are made with metals? Cooking utensils such as saucepans, kettles and boilers are made of metals because they are good conductors of heat. Metals are good conductors of heat. Metals that allow the heat to pass through them are called conductors. Materials like copper, iron, aluminum, etc. are good conductors of heat. So these metals are used for making utensils. Let's consider an activity. Take a metal rod. Clamp this rod on a stand. Fix a pin to the free end of the rod using wax. Heat the metal rod with a spirit lamp or a candle. What do you observe after some time? Does the metal rod melt? No, because it allows heat to pass through it. It is a good conductor of heat. You will observe that the wax melts and the pin falls. This activity shows that metals are good conductors of heat. Consider another example. Can you hold a metal pan which is without plastic or a wooden handle? Perhaps not. Why? Definitely you will get burned, right? The wood is a bad conductor of heat that protects your hand. Did you see a soldering iron? Soldering iron is made of iron with a tip made of copper because copper is much better conductor of heat than iron. And aluminum is used in computer motherboard and LED lights because it is a good conductor of heat. The best conductors of heat are silver and copper. Lead and mercury are comparatively poor conductors of heat. Now let's consider another activity. Look at the electric circuit. Try to set up the electric circuit like this. Here you can see a battery is connected to a torch and a coin using two wires. While touching the wires on the coin, you can see that the torch starts glowing. Replace the coin with an iron nail, sulfur piece and a piece of coal. Similarly, test the materials and record your observation. Now, try to group these materials into good conductors and poor conductors of electricity. You might have performed this activity with various objects in class 6. Try it and find out the conductivity of electric current using different materials. You can see that materials like iron nail and the copper coin will allow the current to pass through it. Thus, the torch glows. But the materials like sulfur and coal piece is not showing any changes in the circuit. So you can conclude that metals allow the electric current to pass through them and are called conductors. And the materials sulfur and coal piece are poor conductors of electricity. Metals that allow the electric current to pass through them are called conductors, while the materials that do not allow the electric current pass through them are called poor conductors. Here you can see some examples of electrical conductors. We'll consider some more examples. The best conductor of electricity is pure silver, but it has drawbacks. It tends to tarnish with usage and it is simply too expensive to run silver wire through a building. Gold is also a good conductor, but that is also too expensive. One of the most commonly used metal to conduct electricity is copper. As a material, it is very flexible and easy to wrap or solder. That makes it the best choice when large amount of wiring are needed. It is the safest and most efficient metal to produce electricity and is comparatively very cheap. Aluminium is another metal known for its high conductivity of electricity. Its density and exceptionally lowest cost make it a very smart choice for many large-scale electrical appliances like electrical power cables, electrical power connectors, etc. and is often used in satellite dishes also. Have you ever tried to drop an iron plate, a metal coin, and a piece of coal on the floor? Do you notice any difference in the sound produced? Let's consider an activity. Take two boxes similar in appearance, one made of wood and the other of metal. Call your any friend, tie his eyes and tell him to find out which box is made of metal by striking both the boxes. He can find it easily by its sound. The things made metal produce a ringing sound when struck hard. Since metals produce ringing sounds, they are said to be sonorous. Silver is the most sonorous metal. Iron is another example. Aluminium, copper, steel, etc. are other examples. All the metals have a shiny appearance. This is called lustrous. All the metals are physically lustrous. Because of this nature, gold and silver are used for making jewelry. Metals are very hard. They can't be broken easily, and we require a lot of energy and strength to break it. Iron is used to make cars, buildings, ships, etc. And here in the picture you can see the wide use of steel. Iron is the base metal of steel, means steel is made from iron ore. That's all about the physical properties of metals. Now we'll move to nonmetals. Here you can see some examples of nonmetals. Sulfur, carbon, oxygen, phosphorus, antimony, silicon are examples of nonmetals. Nonmetals exist in all three states of matter. The majority are gases such as nitrogen, oxygen, hydrogen, etc. Brahman is a liquid, and sulfur, phosphorus, etc. are solid state. Let's see the physical properties of nonmetals. We have discussed that some materials like coal and pencil lead are break up into pieces while stacking with hammer. They break down into powdery mass on tapping with hammer. They are non-malleable. Non-metals are non-malleable. Some non-metals, solids, can be broken by applying some stress. They are called brittle. Brittle means non-ductile. Diamond is an exception. Non-metals are brittle. We have discussed that a hot metallic pan can't hold or touch without a plastic or wooden hand because the wood is a bad conductor of heat. So we can say that non-metals are poor conductor of heat. The non-metals do not allow heat to pass through them, are called poor conductors. So non-metals are poor conductors of heat. Non-metals are insulators. As we discussed with the circuit, the materials like sulfur and colpiece are poor conductors of electricity. They are called insulators. Here you can see some examples of insulators. Rubber, oil, diamond, wood, glass, plastics, etc. are insulator. The screwdriver used by electricians has a plastic or wooden handle. Can you guess why? Because the front portion of the screwdriver is made of iron, which is a good conductor of heat and electricity. So to prevent the electric shock, the handles are made of non-metals such as wood and plastic. They are insulators. Non-metals do not shine, they are dull. So we can say that non-metals are non-lustrous. Two non-metals are exceptions to this, that are graphite and iodine. Have you ever seen wooden bells in temple? Can you guess the reason? Non-metals are non-sonorous. They don't yield a ringing sound when they are struck. The majority of non-metals are gases, so they can't produce sound. So, non-metals are non-sonorous. Non-metals are soft. Example is sodium is a soft metal. That's all about the physical properties of non-metals. Let's recall what we have learned today. We have learned the physical properties of metals. Metals are malleable, they are ductile, they are very strong and tough. They are the conductors of heat and electricity. They are very shiny, means lustrous. They produce sound, so they are called sonorous. Physical properties of nonmetals. They are non-malleable, dull in appearance, they are brittle, bad conductor of heat and electricity. They are non-sonorous, they are very soft. We have 24 non-metals known today. In that 12 are solids, 1 is a liquid and other 11 are gases. So, we have learned the physical properties of metals and non-metals. You can get the link of the notes in the description box. Here you can see the comparison of metals and non-metals. From that easily you can learn the concept. Don't forget to like, share and subscribe the video. Visit the Facebook page and gets the notes of physical properties of metals and non-metals. We'll be back with the chemical properties of materials. Till then, bye. Take care. Thanks for watching. See you soon.